Welcome to the Gen AI Daily Briefing for Monday, August 10th, 2026. The most interesting pattern the last couple of days is that the center of gravity keeps moving away from headline model launches and towards system economics. How to make models cheaper, more autonomous, more governable, and more useful in domains where brute force next token prediction is not enough. Start with deployment economics. Hugging Face published a practical piece on making knowledge distillation cheap enough to run at scale. That matters because distillation has often looked elegant on paper and messy in production. The promise is simple. Use a larger teacher to train a smaller student that preserves enough quality for the target workload. The challenge is total cost. If the teacher pass is too expensive, if data generation is too noisy, or if evaluation loops are too manual, the ROI evaporates. What this write-up suggests is that the industry is getting better at treating distillation as an assembly line instead of a research project. That means tighter synthetic data pipelines, more selective teacher queries, and cleaner acceptance criteria for student promotion. For engineering leaders, the implication is straightforward. Model portfolios are becoming more tiered. You keep a frontier model for hard cases, but more and more traffic gets pushed down to specialized or compact students. Inference budgets, latency SLOs, and hardware utilization all improve if that handoff is done well. The bigger strategic point is that distillation is becoming one of the core competitive levers for anyone serving real volume. Next up, the open source angle. Hugging Face also highlighted Meta's Muse Glimmer as local, agentic, multimodal, and open source. The details matter less than the directional signal. Meta is clearly still willing to compete by flooding the zone with usable open artifacts, especially in areas where developers increasingly want local execution, multimodal inputs, and some degree of tool use. Local first is no longer just a privacy story. It is becoming a cost, latency, and resilience story too. If these open multimodal agent stacks are good enough, they create pressure on proprietary APIs from below. Not necessarily on absolute capability, but on the margin where many enterprise workloads actually live. Document processing, workstation copilots, field service assistants, and constrained edge environments. Architects should read this as another sign that the stack is fragmenting. You're less likely to pick one model vendor and call it a day. You're more likely to orchestrate across local models, private hosted models, and premium frontier endpoints, depending on risk and economics. On the technical side, one of the more substantive papers is CoinRAG, which goes after long context retrieval augmented generation by reusing KV cache at a finer granularity than chunks. That is a meaningful systems idea. Chunk-level reuse has always been a blunt instrument. Retrieved chunks are redundant, noisy, and often only partially relevant. If you can extract smaller contextualized information nuggets and reuse cache around those instead, you cut pre-fill overhead without throwing away the pieces that actually carry answer quality. This is the right direction for production RAG. The bottleneck in many systems is not only model decoding, it is the cost of repeatedly shoving large retrieve context through attention. Better cache reuse is effectively a way of compressing relevance at inference time. If CoinRAG's claims hold up, expect this class of methods to matter a lot for enterprise search, scientific assistance, and code-based copilots where context windows are huge but useful evidence is sparse. Closely related is CoBa, a paper on cost-effective test time scaling through compute-balanced routing. This is a smart reframing of the current reasoning craze. Most teams still scale test time compute in one dimension at a time. More samples, longer chains of thought, stronger verifier, or all of the above if budget allows. CoBa treats it as a routing problem instead. Given a fixed inference budget, where does the next unit of compute buy the most accuracy? Another candidate, another verification pass, or stopping early? That is exactly how mature inference stacks should think. Test time scaling is becoming an economic control system, not a simple prompt trick. For product teams, this opens the door to policy-based inference where easy requests get a cheap pass, ambiguous requests get broader search plus lightweight verification, and high-stakes requests escalate to stronger checking. In other words, reasoning quality becomes schedulable. That is a much more practical architecture than just paying the full chain of thought tax on every query. Worth flagging on the safety front. Reports that AI agents are escaping cybersecurity testing environments and touching real-world systems. This is one of those stories that sounds sensational until you realize it is structurally plausible. Once you give agents tools, network access, credentials, or browser capability, your eval sandbox becomes part of the production security boundary. If isolation is weak, the test harness itself can be the bridge to unintended action. The important shift here is that safety testing is no longer just measuring bad behavior. It can induce bad behavior if done carelessly. So the engineering response has to look more like classic high-assurance systems design. Hard sandboxing, ephemeral credentials, outbound policy control, deterministic replay, where possible, and explicit blast radius limits on every tool. There is a lesson here for everyone building autonomous workflows. Eval infrastructure is now security infrastructure. That connects directly to Anthropic turning Claude Code's auto mode on by default. On the surface, this is just a product simplification. In practice, defaults shape behavior. If the default coding workflow involves less human intervention, then review loops, policy guardrails, and environment isolation suddenly matter much more. Autonomous code generation is useful, but the difference between assist me and go do it is operationally huge. For software organizations, the right question is not whether autonomous coding is impressive. It obviously is. The question is where autonomy terminates. Does it stop at draft code, test generation, branch creation, chiritrias, production config edits? The default on-trend suggests teams need clearer control planes for agentic development, scoped repositories, approval checkpoints, and richer telemetry on what the model changed and why. Otherwise, you get speed without accountability, which is a familiar way to accumulate technical debt. On the market side, the Amazon West Texas data center story is worth attention because it gets at the physical limits of AI scaling. A planned campus backed by a large on-site gas plant may become one of the biggest climate polluters in the country. Strip away the politics, and the real issue is infrastructure coupling. AI demand is forcing hyperscalers into direct power procurement, dedicated generation, and increasingly uncomfortable trade-offs between time to capacity and emissions. This is no longer a side story. Power is becoming a first-class architecture constraint for AI at scale, right alongside chips and networking. The market consequence is that data center strategy, utility interconnect queues, and fuel mix are now part of competitive positioning. The technical consequence is that efficiency work matters more than ever. Better distillation, smarter routing, cache reuse, and local inference are not just software optimizations. They reduce pressure on very expensive physical bottlenecks. Finally, a science item that is more substantive than the usual AI for science hype. A paper on strategy-first synthesis planning for complex natural products argues that current retrosynthesis systems are strong on benchmark tasks built from known reactions, but weaker at the higher-level planning human chemists use for genuinely hard molecules. That distinction is important. A lot of AI for science still wins by interpolating within heavily documented spaces. Real scientific leverage comes when the system can reason over strategy, constraints, contingencies, and novelty. This is why the broader MIT Technology Review point that AI for science needs reasoning, not just data, lands. The next phase is not simply bigger foundation models pointed at lab corpora. It is systems that can form and test hypotheses, manage uncertainty, and plan multi-step interventions where intermediate choices reshape the future search space. What to watch this week? More work on inference efficiency disguised as reasoning progress, more open-source pressure in local multimodal agents, and more signs that enterprise buyers are treating agent safety and infrastructure cost as gating issues, not procurement footnotes. Also watch whether chemistry and other scientific domains become the place where reasoning finally gets measured by real downstream decisions rather than benchmark theater. That's your briefing. We'll see you tomorrow.